Hi there. Let's look at electrolysis. You have two situations of the same electrochemical cell. Left is a functional one, 1.1 voltage, and the right is already dead. It's 0 voltage. So why? What happened is on your left, the zinc has a lot of electrons in electrode, and then it pushed to the right because the copper electrode has less electrons. That's why the copper is cathode, the girl, the red cat, and it pulls the electrons out of the zinc through the wire. Now, once it's done completely, you're going to see on your right, the copper is filled and the zinc is eaten away, and it's a dead battery. Ecell is 0. So that's what the situation. Now we can reverse that. And what we can do, we can actually pump the electron opposite side, or reversing the current opposite, by putting a battery in the place of where the voltmeter. If you do that, the zinc is going to get 2 electrons because you're reversing the current. It's going to become the cathode, the red cat. And zinc 2 plus in the solution going to get 2 electrons and deposit onto the eaten away zinc electrode. So, and also the copper, big fat copper electrode, going to dissolve this copper, right, by Leo, and make more copper into the solution. So therefore, this big fat copper electrode will become the normal electrode, copper electrode, and zinc will be filled back. So now we can calculate the Ecell, red minus ox. Just put the numbers, right? Zinc value is minus 76 and copper value is plus 34. Put together, it's minus 110. That's why it's dead battery. So it's non-spontaneous. You need to put the DC on the battery to the opposite direction of the current, right? So that's why it's an electrolysis. So what we know, electrolysis needs energy. And still, the cathode does the reduction. It's never gonna change, right? So also, we can calculate the electricity, how much the cell potential, it's same calculation, and we have to supply that in the positive same value. So in this case, we supplied 1.1 positive volt to reverse the zinc copper battery, right? We're going to look at a different situation now. Look at this one. If you have sodium chloride solid, it won't do anything, but you have to heat up to 800 Celsius. When you heat it, it becomes sodium chloride liquid, the molten. The molten salt will have sodium plus and chloride ions moving around. So now we can put a battery or the DC source on the top, and we can see what happens. The platinum and the carbon electrodes are just inert. They're just there to support it, to pass the current. But when the electrons come to the platinum, what happens is only thing can go there is sodium plus. It will pick up an electron, becomes sodium. Look at the other side. The chloride will go to the anode and dispatch an electron and become Cl2. Just for the balancing 2, Cl minus is Cl2 and 2 electrons, and it's Leo oxidation. See, the minus oxidation number went to 0. In the other side, sodium plus went to 0. So that's why it's cathode gaining electron is reduction, right? So you understand those stuff. But here, what's the whole point? The solid sodium chloride didn't do anything, but the moment it's molten, it will pass electricity, right? And also, it will make chlorine on your anode and sodium on your cathode. So we can see how much does it cost for this DC source. So the red is minus 2.71, ox is 1.36, and then put them together, minus 4007. So this is a non-spontaneous reaction. This will not happen simply. So you need to pump that DC power little more than 4.07 voltage, right? And 800 degrees of heat. So it's going to be very expensive to make chlorine on your anode and also make sodium on the cathode, right? But actually, sodium is a liquid when it makes, because it's 800 degrees, right? So what do we need? We need more than 4.07 voltage, positive, and we need anode to make the chlorine. So normally carbon, platinum would work, and cathode makes sodium liquid. And this is a non-spontaneous reaction. That's why we need a direct current source on the top. Now also, this one will we need this delta G is minus NEF, and that's I will discuss at the end of this video. Okay, now let's look at another situation. This one, you have platinum and carbon and the DC source on the top, and you have liquid water. So liquid water, what can happen? So the liquid water going to make oxygen and release some electrons, and it'll need 1.23 voltage. In the other side, same water going to make hydrogen, and it needs minus 0.83 voltage. So these are the two possible reactions. Now what happens in the anode, the LEO that will make oxygen in the anode, and in the the cathode will make hydrogen gas. So that's simply making oxygen is oxidation and making hydrogen is reduction, right? Now we can plug into the formula, and Ecell is red minus ox, plug in the values, what we get. So this is, yes. So we will get minus 2.06 volt. So again, it's minus value, non-spontaneous. What do? We plug in a battery DC current plus 2.06 volt onto the DC source. We put a battery there, we can get oxygen in the anode and hydrogen in the cathode. Now also remember, pure water would not do this. Simply you need something like KOH, sodium hydroxide, 1 molar, 0.5 molar, just to make ions, electrolytes running through the system. Got it? Now there's a little caveat I can add. So now you have hydrogen and oxygen gas. You can put it into 2 tanks, and you can actually put an electrode in between the two, and they can react actually. Then it'll make water vapor, and it will make electricity, this 2.06. Don't try at home, you should not be, right? But if we can, we actually use this method when we land on the moon. We had this technology then. Now today we are trying to use it for trucks, right? You could be the next Elon Musk if you come up with a better solution like that, right? Okay, so let's look at about the electroplating. Now let's say I got a bronze star and I have a silver ring at home. So I would like to make my bronze star into a silver star. So what do? You put the bronze star into the cathode and put a DC source on the top and hook up the silver ring, and voila. In the cathode, it'll make the silver deposit onto the bronze star. In the anode, it will eat away a little bit, atom by atom, the silver ring. So the same material, same reaction happening opposite directions, right? Now, if you like to make your silver star to a gold star, you can do it. All you need something like electrolyte with like gold chloride, and then you put a gold ring on your anode, and voila, you can get it done. So you just need a little current on the DC source, right? So that's what the electroplating, actually very simple. And then electro refining. What's the refining is actually we have impure metal, sulfides and oxides, and we're going to purify up to 99%. So what you need, something like sulfuric acid solution, and then we call the pig, the zinc, copper and some other metals, and you put that one into the anode and put a DC current and put it to the other side. There's some sort of a wire mesh, and what happens with the acid reaction, the zinc, copper, platinum, those platinum won't, they dissolve first. Now in your anode, what happens? First deposits your cathode. First deposits copper because it's 0.34 volt. Then it deposits zinc and so on. So that's how we actually refine metals. Okay. Now there are 3 equations we need to know later on. So delta G is minus NFE, that's the Faraday and the cell potential. And there's another one, Q is IT, that's the Coulomb and amperes times seconds. And the other one